3-minute videos with Daniel. Today, we will now solve question 1G of MET Oxford 2007. Question asks to find the graph of this function. Let's break up this function into 3 parts. This exponential part, this sine squared part, and this x squared part. Actually, the third part is actually both of them because the sine contributes to the x squared and vice versa. Now let me get a new marker because this one's running out of ink. And here I am with my new black marker. Let us do this. What do you think this is? Exponential decay. So we have our block skeleton on the curve going this way. Next, we need to find the intercept at x equals to 0. Obviously, this will become 0, and when one term is 0, all the products will annihilate to 0. So y is 0, so the graph starts here. And how about the sine squared? Well, this tells us that the equation is behaving like sine, but a more timid version of the sine which doesn't want to go under the negative axis. Well, anyway, that's a really funny joke. So let's move on. How about the sine x squared? Basically, sine x looks like this. It's periodic, but sine x squared has no period at all. In fact, if I just draw the positive bit of the curve, it looks like this, and then it will a mess. So what it will look like if we multiply the 3 graphs together, or rather do this, because it will look like this, and then there'll be more wiggly squiggles around here, and boom, we got our graph. And how about we just try with 2 power negative x sine squared 1 over x. Now, what we try sine 1 over x, then you have this mess here, x equals to 0. Then you have this nice curve behaving at asymptote to 0. Let's just try with the mess here. Oh, that's a rather interesting function, and you can experiment with all combinations and shapes and sizes of sine and x until you finally encounter a monster like 1 plus 4 sine squared e to the power of x to the power of 146. Maybe you could try buffing that out and send it to me. That's for this interesting function discussion, and if you try figuring out these functions, make sure you can figure out where the clean bits are, which is here, and where the messy bits are, which is here and here. Notice that the 1 over x bit is a lot messier because 1 over x, the graph of 1 over x looks like this. And basically you're trying to fit more numbers in the space of 1 rather than some odd numbers in the space of 1. So basically you're trying to fit infinite number of integers in the space of 1. It's like putting a lot of needles inside a space in the size of a needle. It's a bit pointless, isn't it? That's why this bit is a lot messier than the x squared bit. Well, see you in another video and goodbye.